Hello again. I'm trying to bash out another low production quality video. Let's pick up where we left off in terms of literate programming and using Quarto as our publishing system to run code and document it in a nicely formatted way so that we're building our skills related to reproducible research. So here's where we left off. If you look at our RStudio window, I called this file A1 for assignment 1 tutorial.qmd. We set a working directory and all that kind of stuff. And now let's actually lean in a bit to using this to its potential. So we're going to try to do a piece of that assignment. And this is what I hoped people would do, and this is where I realized if I hope that you will do something, I should tell you to do it instead of thinking you might be able to read my mind. So, we're going to do an assignment about literate programming in Anscombe's Quartet. And the idea was to make that classic figure to articulate the reason why visualization really matters. And so let me set it up like this. So I'm going to go ahead and leave the YAML. Remember, this is the YAML header. YAML stands for yet another markup language, I think, or something like that. And I'm going to go ahead and leave that in there, title, author, in the format HTML. We'll get into the power of that header in a little while. But I will go ahead and, instead of the incredibly unimaginative first level header, let's go with Anscombe's Quartet. All right, and then I'm going to write a little preface here. I'm going to say the purpose of this assignment is to demonstrate how summary statistics can sometimes be misleading and how data visualization helps us understand our data set. Okay. Now, we can format that or however we want, but I don't know, whatever. All right, so the next kind of section of the document, let's not make it something called Quarto. Let's say, let's call it the data. And you notice, so for the first little header, I chose to write in all caps, and then for the next headers, I'm writing in more sentence case. That's just a choice on my part. We can easily go back and change things depending on how our document looks. And now here, I'm going to get rid of this stuff, and I'm going to say something like Anscombe's Quartet is comprised of 4 pairs of X, Y data. And let's get rid of this. And now what we want to do is, if you think about like the consumer of this information, say you were writing this up and you were me and you were trying to teach students what the heck was going on with Anscombe's Quartet. That's the logic that I think we should engage in. So we have to show them, okay, what do I mean by Anscombe's Quartet? And so that's where we're going to use this code chunk and we're going to show them that. And here's the thing. What I did is I went back to the lectures and I enabled some tools that are going to be much more helpful for you guys to sort of copy what I'm doing, modify it, figure out what's going on. And so now the thing that I don't know is whether GitHub has sort of fully activated those changes I just published. But let's go ahead and see. So we're back on my website. I'll go to the homepage for the course, and you can see. Yeah, it looks like it worked. So I've posted that first tutorial. There it is. And I want to go to, there's assignment 1, but then in lecture 1, that's where I introduced the concept of Anscombe's Quartet. So if we go through here, and you can see my really poor skills in terms of laying slides out. What we're talking about is, visualizations, creating this external representation and offloading all of that cognitive task, and we're going to illustrate that point with Anscombe's Quartet, where we will reveal details of these data set that are not revealed in the summaries. And so if we go down here, what I've added is an option in my YAML header for this slideshow called code fold, and I've turned echo on, so echo is now true in terms of a key value pair. So now in the slides, when you're following along or whatever, if you want to see, okay, so how did I do that? So there's Anscombe's Quartet. It's not formatted very well, but anyway. You can just click on that and it creates that. And if you want to copy it, you can go and click this little thing, and now it's in my clipboard. And so now if I get rid of this little cheater thing and I just paste that into my code chunk, awesome, there it is. I got a bunch of extra library stuff in here that we might not end up using, but we shall see. And remember, you can always check to see if your code is sort of viable by hitting this little play button, and it loads some libraries and all of that kind of stuff, and didn't throw any error messages. And so you can disable this preview if you want. And so this works, and I'm just going to clean that up a little bit. And again, you can go up here and let's just preview it in the viewer pane, and you can hit render, and it'll go over here, and we'll see. Okay, so what's this looking like? And we can see. All right, here's the title, and this dummy is the author, and here's our thing, and we're guiding the reader through the logic of what we're doing, right? Anscombe's Quartet. Let's show people how summary statistics can sometimes be misleading and how data visualization is important. The first section is the data, and here's our thing. Anscombe's Quartet is comprised of 4 pairs of XY data. Now, it's doing the code thing. It's saying, here's the code you did, and we're getting all of this stuff, right? Okay, and then this is the result, and you can see the XY pairs. Okay, I don't like it, right? I would rather have people be able to see that if they want, but not be distracted by it in terms of reading through the stuff. And so let's do this. I think this is going to work, but I don't know. Code fold true. We can put that up in the YAML header, and it will do that for all of our code. So it's like a big meta thing for the whole document. Now, alternatively, if we want to have tighter control, I could have gone down here and gone, now to do stuff down here, you might remember we do a number sign and then that vertical pipe and then a space, and I can go echo, and it's saying, oh, echo, huh? And then I'll select true, and then I could do code fold true. I can do other stuff here as well. And so you can do that in a code chunk, or you can do it in the YAML header. I'm just going to keep it in the YAML header for right now. So I'll delete this. And let's just see what happens if we turn that on. Okay, so, and remember, we're in this preview mode, so that's fun. So we'll hit render, see what happens. Okay, now the it's working. I can click code, and there it is. But it's also putting this, and then here's more code, right? And the reason is that we are doing some stuff that when we execute the tidyverse thing, when it loads that library, it loads a bunch of other stuff, and so it's telling you that it's doing that, right? And so that's why it's breaking it in half, and it's like, well, that's dumb. I don't like it, right? I don't want this stuff. I just want that stuff. And so the way to do that is to break up the code chunk. And so let's keep that stuff up here as its own code chunk, and then let's make a new code chunk that contains the actual command that we want, that generates the data that we want. All right, so here's what we did. We have our code fold option, so we want people to see this. This is going to be a little clumsy, but we'll fix it up later. We want to show people the data, but we also want them to be able to see the code that we used to generate the data. I was trying to hide the output from some of the library statements. That's not really particularly compelling. And so what I did is I split the code chunk up. So they both have code fold turned on, but for the library statements, I suppressed the output. So we're not getting that feedback about like what other packages it installed and things like that. And then in this next code chunk, I just wrote this command, which is essentially says, show me the data set called Anscombe, right? And that's what this is. And it shows you the X1, X2, X3, X4, and so forth, the Y things, right? So now what we can do is we can say, okay, so those are the data, right? And if you guys all want to imagine what's going on here in terms of your own data, right? Imagine you have a hypothesis, and so let's put these in, right? Let's call this example hypotheses. And I'm going to just make a list, and I'm going to go 1. Eric has 4 replicates in which he is measuring the expression of 2 proteins. One is called X and one is called Y on 11 samples. So you got 11 samples in each replicate. You measure 2 proteins, right? Now let's do Cody has 4 replicates in which he is measuring gene expression of 2 genes. We're going to call them X and Y. In 11 cell images. All right? Trying to just frame this in a way that makes sense to everybody here. And again, this is going to be a video that takes 1 billion years, sorry. 3, Ronald has 4 replicates in which he is measuring a blood protein, now the X, and a mosquito mark. I don't know what you're gonna measure something in the patient, on a malaria marker. that'll be Y in 11 patients. Now, I don't want to take a bunch more time. I know there's a couple more people, but you guys get the idea. We could do this for GN in terms of mineral data. We could do this for Nathaniel in terms of nematode, invasions and things like that. You get that, okay? And here's the thing. Your hypothesis is that the 4 replicates are not different, right? Your hypothesis is that they're true experimental replicates and and that kind of thing. So your hypothesis is that the 4 replicates do not differ in the correlation between X and Y. I mean, significantly, right? Like, maybe there's some error, but you're trying to estimate a correlation coefficient. You got some replicate data. Okay? And then we can, let's bold this to really kind of call it out to our hypothetical students. Like, this is the point. All right? So, what would you do? You would calculate the correlation coefficient. You would calculate the summary statistics for those 4 replicates. So, let's do that. Summary statistics. Okay, and again, I'm going to go back and I'm going to find, there's lecture 1, okay? And again, I put this code fold option in, and so that allows you guys, we're not really learning R yet, right? So I'm, copy this in and we'll figure it out. So hit this clipboard thing, move this out of the way, and then let's go back here and we'll replace this with this code. And so just to walk you through what's going on here, so I am creating a new data set called Tidy Anscombe. Because here's the thing, the tool I want to use it's not efficient. It's like the way these data are organized. It's not what we call a tidy data set, and that's what the Tuesday lecture was meant. We were going to get into that, but anyway. And so I kind of want to reorganize it. You don't have to. There's lots of ways to plot this. Like Eric was doing this in base R, and you can just do a loop, and there's in all cases in this class there will be many different correct ways to approach a particular problem, right? So, but in my case, I don't want to do it that way. I want to make this data set a tidy data set in that I want it to sort of be a longer stack where it's got a column for X, a column for Y, and then we can calculate and a column for replicate. And so that's what this does. So let's see if this works just by pasting it in. We hit that, and we did a bunch of things. So one of the ways you can do this is you can, what'd I do? I collapsed it. There we go. So let's go into our environment, right? And so we had the Anscombe data set, which I saw, and then what I've done is I've turned it into set, has 4 possible values, 1, 2, 3, and 4. And then there's a value for X and a value for Y. And, the observations don't really matter, but we could have added that as well. So this is my environment. This is when I create data frames and other things like that. They end up here in R. I'm less sure what happens in Python, but we'll cross that bridge when we come to it. I did figure out how to do the Python thing, but I'm not sure I'm going to get that video done tonight. Anyway, I ramble. So we created this thing called Tidy Anscombe, which is a data set with set X and Y as columns, and it is 44 observations or 44 rows. And then the next thing is I'm creating this Tidy Anscombe summary, and I'm essentially saying, hey, take this Tidy Anscombe data set. This is called a pipe. It means I'm not done telling you what to do. And then you can go to a line break, and it makes your code easier to read, right? Take this Tidy Anscombe data set and group by set. So for each set, 1, 2, 3, and 4, summarize across all of the columns, and here's the functions I want you to do, and this is a list, right? I want you to do the minimum value, the maximum value, the median value, the mean value, the standard deviation, and the variance. And I'm going you to keep the names in this thing, right? Now this is that other guy's code that I referenced in the lecture and elsewhere. I wouldn't have known how to do most of this stuff, right? This is like a comment he left in. So, and then we have these variables that we set up in a vector. And then I'm really bad at naming data frames. And then I'm like, make a new data frame called thing. And it's a data frame that is the tidy Anscombe summary, but only use the variables I tell you. And then make a table out of it. Okay? And so if we now render this, and we go back over here, we've got our library stuff, the code that makes that. Example hypothesis. Well, you guys didn't stop me and say, hey, you misspelled the word hypotheses, right? There's our example hypotheses. Right? Your hypothesis is that the 4 replicates do not differ, and then here's the summary statistics. Sure looks like they don't differ, right? There's this table. And if you want to know how to get the table, there's the code. Okay? And then one last thing. It's like, oh, okay, wow, yeah, they're the same. Yay! I can use these as replicates or whatever. Everything's great. And then the data visualization nerds are like, oh, wait, are you sure? Are you really sure? And so we're going to add one more section, and we're going to say visualization reveals hidden patterns. I don't know. Let's put an exclamation point. We're excited. And then we got one more set of code. And so I'll do the 3 ticks, and I'll say I'm going to use R because I don't know how to use the other things. And then 3 ticks. And then it's like, okay, now I want to make this graph. And once again, what I've done in the lecture is I have put this in. So there's the graph that we're going to try to recreate. There's the code. Let's copy it. Get rid of this. Paste it in here. Right? And you can see, so I'm using ggplot, and this is what I know how to use, and so I like it because if we give it a column of variable names like x and y and set, I can say, hey, make me a plot. Use this data set called tidy Anscombe. The aesthetic is like, this is how I want you to lay things out, how I want you to want it to look. The x variable is conveniently called x, and like in Eric's experiment, it would be protein 1 or something. And the y variable is conveniently called y. In Ronald's data, it might be, malaria antibodies or something. Who knows? I don't know how that stuff works. But that's how I want you to lay it out. And then I want you to do the geometry that we're going to use is a point. It's a scatter plot. Okay? There's lots of things we can do to control this stuff. But also, by the way, I want to plot the averages. And so I'm going to use the tidy Anscombe summary data set for this one. And I want you to plot the x mean and the y mean in a red of size 5, but turn the legend off. I don't want to, And then here's the best part, right? The layout faceting will just take care of it for you. So I was just like, okay, I want you to facet it by this other variable, set. And I want you to create a line that is based on a linear model. Don't use the standard errors. And so now, when we render this, right, we've got all this stuff. The preview looks good. We didn't. Okay, so the one thing is, like, I don't know if this is a warning or a piece of output. We could figure out how to suppress this, but I'm not going to worry about it right now. So if we wanted to see the code, we could see that, or we can turn that off. And now we have this Anscombe's Quartet. you know, I mean, I guess one last thing is like we could add figure captions and stuff like that, but I feel like the video is long enough already. It's half an hour. Oh my god. Okay. And so now we've always done this previewing thing, right? And you know, I'm going to go ahead and save all of the stuff that I did, right? And then we can also, there's a lot of different ways to do this, but I can switch over to preview in window, hit render, and it'll automatically dump it into an HTML file and like send it to my open browser. And so this is, you can see it's using a local, it's like the, you know, it's making its own window. And here's the thing. So Anscombe's Quartet, here's the data, the rationale. Again, we're combining our logic with the code's purpose, and that's really what I wanted to get across, and I failed to do that. So, and people can see the code or not, or, you know, example hypotheses, and I fixed the hypotheses, the summary statistics. Now I'm looking in here and I'm saying, like, I could put a thing in here that says, we might conclude that these data sets are largely identical and the replicates are the same. And then visualization reveals hidden patterns, and then that's the figure. So that's the basic idea. So I'm going to call it there. It's only a 28-minute video, sorry. Hopefully you guys have a chance to watch this before class. And I did figure out how to make Python work, but there's no way I'm going to have a video made for that. So I'll see everybody in class. Thanks for sticking with me.